The gain of amplifier with feedback is always larger than the original gain of the amplifier. Mod AF is greater than mod A. And if we find the product of open loop gain and feedback factor, open loop gain is given by capital A and the feedback factor is given by A beta. So the whenever you do feedback amplifiers, you will always find this value of A beta. A beta is A into beta. A is called as the open loop gain or the gain of the amplifier without feedback, and beta is called as the feedback factor. So if you put A beta equal to 1, what will happen to the gain? In this equation, put A beta equal to 1. What will happen to the gain? AF. What is the value of AF if you put A beta equal to 1 here? A by 0. What is A by 0?
Infinity.
Infinity. You can see here AF is infinity. I have already told that the output voltage is keeping on increasing here, right? So at one point, the gain of the amplifier reaches infinity. So when enormous gain is produced by the amplifier, it is not going to be stable. It is going to be unstable. So it starts oscillating. So when something is constantly larger, it becomes unstable. Any unstable component will oscillate, right? So here the gain of the amplifier with feedback is infinite. So what happened? This leads to an oscillating effect. So if I'm going to give positive feedback to an amplifier, it acts like an oscillator because the gain reaches infinity and the circuit becomes unstable. As the circuit becomes unstable, it starts oscillating and generates oscillations of a particular frequency. So the positive feedback is going to make your amplifier unstable. See here, it increases the instability of the amplifier. So it is going to make your amplifier unstable. It is going to reduce the bandwidth. It is going to increase the distortion and noise. So I cannot use this concept of positive feedback in amplifier because it is going to be all negative points. Stability is very poor, bandwidth is very poor, noise and distortion are very high. So I cannot use this as an amplifier, but I can use this as an oscillator. So as I told you, in one place you don't need a component. That component will be needed anywhere else in electronics, right? So same way here, positive feedback amplifiers are not suitable for amplification, but they are very well used as oscillators. So this property of positive feedback is used in oscillators for generating signals. So oscillators are circuits which generates AC signals. Okay, so if you want to generate a sine wave, if you want to generate a square wave, or if you want to generate a triangular wave, if you want to generate a sawtooth wave, so all these oscillators can be used. So this is your sawtooth wave. All these oscillators can be used. So oscillators are going to generate AC signals just by using a DC bias supply. Okay, so positive feedback is not useful in amplifiers, but it is very much useful in oscillators. Okay, so we are using this negative property of positive feedback in oscillators to generate oscillations, whereas it is not suitable for use as amplifiers because of highly unstable nature of your amplifier, poor bandwidth, and the noise and distortion are going to increase. Whenever the output voltage is increasing exponentially, the distortion and noise and other parameters will also increase exponentially. So the circuit becomes more and more noisy. This noise is going to be very much useful for me in generating oscillations. So that is going to be tapped here as an application for generating oscillations. So remember, positive feedback amplifiers are unstable, but they are going to be very good devices for generating oscillations.